Imagine you're a college student or you're getting ready to go to college, and you keep hearing about this thing called research from your guidance counselor, your academic advisor, your parents, the college brochures. You hear phrases like transformative, rewarding, and a great resume builder. Today on the WPI Podcast, you'll hear why getting involved in research as a student is all those things and more. Hi, I'm John Kane, and this is your home for news and expertise from the classrooms and labs at Worcester Polytechnic Institute. In this episode, you'll learn what it's like to work in a lab as a student, what you can learn from research experience, and why some aspects of it might challenge you. And we'll talk about how to find student research opportunities. Our guest today works with undergrads and grad students at WPI to conduct research on fiber optic sensors for improved safety and efficiency in food production and healthcare instruments. Yuxiang Shawn Liu is an associate professor in the Department of Mechanical and Materials Engineering at WPI. Shawn, thanks for being on the WPI Podcast.
Thank you for having me.
Shawn, first off, a lot of us who work at universities throw around the term research a lot, but research can mean a lot of different things to different people, and not everybody knows what research inside a university laboratory looks like. So how do you answer the question, what is research?
The short version is research is doing something new. That's it, period. Different people interpret this something new differently. This could be explore new knowledge. It could be explore new understanding. It could be realize a certain new function in a certain applications. It could also simply just be, educate people and then develop skills. So these are all the goals. The longer version of what research is, I'll go through this kind of step-by-step procedure of research. First of all, research always starts from identification of a problem. And after that, we are trying to solve that problem, but it's not just as simple as just go ahead and solve it, right? So we have to really formulate a question from that problem. Very commonly, the question that we are trying to answer from the research is not exactly the same, and sometimes it's very different from the problem we are trying to solve in the real world. After that formulation, we want to idealize the solution as well as how we can prove it. Until this point, we don't do anything yet. We essentially just think, brainstorm. And then next step is to prove it. We'll have to think about detailed setup. We'll have to find constraints and available resources. And we'll have to identify what we are missing. We'll have to make purchases. We have to talk to people and see whether we can find those. And then we plan for activities. So this is the real hard work thing. So either it'll be experiment setup or it'll be a numerical simulation in a computer world. Do it. So that do it, just two words, but takes most of the time. Mm-hmm. And after that, we'll find the results, and then we evaluate whether it's a failure or it's a success. And in most of the cases, it's a failure. So the good thing is it's not 100% failure. There's always something goes right. So we are trying to evaluate and then decide what to do next. And at the end of the research, we need to show these results by organizing all this motivation, results, proof, and innovation into publications. That's it.
And Shawn, there's a lot of different ways that students can get involved in research, and it may differ a lot based on their level, whether they're undergraduate or graduate student. I'm really curious about what research looks like for undergraduate students, since a lot of them may not necessarily have tried this before or have had this opportunity to do research in a lab before.
Let me just put myself into the undergraduate student's shoes and then try to answer that question. First of all, I'm, let's just say, a second-year sophomore students who have been sitting in the classroom for more than 10 years, right? Yeah. So what the research would look like to me is, one, it could be the first time that I will have a playground that I can freely get my hands on the expensive equipment. I can try all these crazy ideas I have. Nobody's looking over my shoulder, and I will just evaluate what I did by myself. Mm-hmm. That itself is actually exciting for me. Second, there will be no textbook. There will be no lecture notes, no office hours, no example problems, no homework assignments. I'm only given by a problem that the professor already formulated. And sometimes the professor even don't formulate for me, and I will have to formulate it myself. So I will have to learn by my own work. I only learn after I work on it. And at the same time, I change my work based on what I learn. So you can see this is a really organic learning process. I can't expect what I will learn tomorrow because that will depend on what I will get by the end of today. And the third thing that is very different from the classroom experience I'm used to is I will fail a lot. That is the nature of the research and the nature itself. Human being, we are trying to solve a problem in the nature. Very commonly, our first 10, maybe 100 tries will end up with failures. That actually is how we can learn from the nature itself. So with that said, I should prepare myself better mentally to deal with these failures down the road.
It sounds really exciting, but also a little bit scary. So we have a lot to talk about today to explore that, all the sides of research, so that folks listening can sort of decide if it's something that they want to pursue. I'm wondering if we could start by talking a little bit about just how students are so important to the research projects that professors do, and just how common is it to have students doing research here at WPI?
In universities, students conduct research, period. So in other words, in most of the university labs, all the research activities are mainly conducted by students, not by professors, surprisingly. So that actually is, very different case from government labs. All the results in my lab, and I think most of the results in other people's lab at WPI, are generated by students. My roles at WPI as a professor is, one, I need to decide the research direction. Mm-hmm. Two, I need to obtain the resources for my students. For example, I have to find the financial resources, technical resources, intellectual resources. And then three, I'll have to oversee and manage the progress of the research. On top of that, I have to teach, have to do some community work. So that's part of the reason why I'm not always in the lab. Mm-hmm. And going back to the technical parts of the research, which I just said, students are really kind of doing those. But the professors are not isolated from those activities. But rather, before students' hard work, the professors will actually join, generally speaking, one-on-one meetings with the students to brainstorm how to idealize the idea, how to plan for the efforts so that we have better efficiency on time and money. And then after the student do the work and the student analyze the data, the professors, generally speaking, will sit down with the student, again, one-on-one cases, right, to discuss which results are good, which are bad, which are useful, which are not useful, and then what to do next.
It sounds like a great partnership, and it's very clear that the students are essential to making research happen and the discoveries that come out of that.
Absolutely, especially when people are getting well along and then both sides have a lot of ideas. There can be very, very close personal relationship even after the student graduates. My past students, generally speaking, always come to me for advice later in their career. And some of them even bring the family issues to me.
Sure, yeah.
And
you spend a lot of time together in the lab, right?
Yes. That's the part of the benefit I get from this profession.
So Shawn, just to paint a little bit of a picture, how many students are working with you in your lab at one time?
In regular years, I have somewhere between 3 to 5 PhD students, and I have somewhere between 1 to 3 master students, and I have somewhere between 3 to 5 undergraduate students working in my lab. And this number fluctuates from, semester to semester, from year to year, but that's the idea. So it's actually essential for me to look for students constantly. As a result, in every single undergraduate course I'm teaching, I will always broadcast I have research opportunities in my lab.
Oh, you have a platform there.
Yes.
Using the bully pulpit. Yeah.
Exactly. Free advertisement.
Yeah.
And I announced this standard bar in my class to the students, but generally speaking, when every single individual student come into my lab in the beginning, I always tell them, there is a standard there. I would say for most, if not all, faculty members who are working on research, for sure they are open to students. It's just different people might have different number expectation of the undergraduate student working in their lab. Again, depends on their nature of the research. Some of the research might require additional time efforts than average expected from undergraduate students. So with all this aside, all this detail aside, I think it's safe to say 90% of the faculty members on campus working on research are working with students.
We'll talk a little bit later in the episode about some of those, base rules that you talk about, the base requirements that you're looking for folks to help in the lab. I wanted to mention before we move on to the next question that Research is a big part of the student experience here at WPI. We're a Carnegie Research R1 institution, which is the top tier of colleges and universities in the U.S. for high levels of research activity. And while we're talking a lot today about student involvement in faculty research projects in the laboratory setting, there's a lot of ways that WPI students gain research experience. Graduate students here are often heavily involved in faculty research, and they work closely on these projects with funding agencies and research partners around the world. And in terms of undergraduates, they also do significant research in their degree programs. First-year students, for example, have the option of participating in the Great Problems Seminar. It's a 2-term experience that immerses them in university-level research and WPI's project-based learning curriculum. The students in that course take on the challenge of solving problems on themes of global importance. And then there's 2 required projects in junior and senior year, and they also go heavy on research, both in a student's degree program and in an interdisciplinary challenge at the intersection of science, technology, and society. A lot of this research is done in partnerships with business, industry, government, or other universities, so these are real-world problems that students are working on. There is also funding sources for WPI students who want to do research. That can include fellowship and scholarship programs and grants for summer research experiences. And we'll have links in the show notes with more information on research at WPI.
Hey, I'm Colleen Wambach, one of the hosts of the WPI Podcast. If you're enjoying this episode, make sure to check out our other conversations exploring the people, ideas, and innovations shaping WPI and the future of STEM. Find us at wpi.edu/listen.
Shawn, for this conversation, we're going to keep the focus on research in a lab with a professor. It really can be a transformative experience and a growth experience to work on research as a student. What are some of the lifelong skills that you think students will gain from doing research with a faculty member in a lab?
I personally think there are absolutely amazing opportunities for personal development and career preparations in research. And I will answer that question in the following 3 categories. One is the technical capabilities, second is the communication skills, and the third one is the career mimicking challenges. When I answer this, I hope the audience can put my answer into the context of AI competition. I'm sure this is a common concern of not just the students, but also the parents. So with that said, the first category, the technical capabilities, in research labs, generally speaking, there are a lot of expensive pieces of equipment. They are expensive not just because they are fancy, they look nice, but because they can do a lot of nice or amazing functions that industry or government agencies appreciate. And they do use, right? So for example, we have a scanning electron microscope, short as SEM. SEM is a equipment that is very expensive, I believe $1 million level, also widely used in industry. This is not equipment that, just by the road and random person can use it. This equipment actually can see samples with a few nanometer resolution. And you can get your hands on this expensive equipment, use the equipment as you like, of course don't damage it, right? And then you put this experience later in your employer's benefits and they will want to hire you, right? So with that said, the technical capabilities is not just to get training and then hands-on on the equipment, but also you would develop deep fundamental knowledge. And this knowledge will be combined with your hands-on and will be well beyond the textbooks and the classroom notes your peer students will get. Also, the technical skills that actually combine the fundamentals you learn from classroom and you learn from your own research work with real-world applications. And my understanding is this will allow you to stand out when you compete with AI. And then hands-on, no matter whether it's experimental hands-on or simulation hands-on, that actually can possibly directly land you on your first job. Then beyond the technical capability, the communication skills is also a very good benefit you can get from research. In research activities, you have a lot of one-on-one communications. You talk very deeply about what are the results you obtained from your whole month efforts, right? And especially when you talk to the stakeholders who are sponsoring the research, and you will develop specific communication skills where those audience from either industry or government agencies will be convinced, right? And then if they are not convinced, they are going to challenge you. And then with these skills, you get a much better position, not just with the competition with AI, but also later in your career. And then this data-based communication skills, you have to present your data in both fundamental level to show you understand stuff in the fundamental rather than you just press the button, you record whatever number pops up. And also you show your data with a non-expert in the audience to allow these non-experts to understand and appreciate your work. And this way to convince this kind of non-expert audience takes a lot of practice. You don't generally get that from your classroom. And then how to convey your challenges through your own understanding to the audience so that you can seek help or ideas from them. Of course, there's group projects in the classroom, but remember, in the classroom group projects, you talk with your peer students. While in the research, you talk to maybe expert working in industry for 3 decades on this topic that you're working on. So this context different actually will help you to develop the more efficient communication skills. And then, of course, later on in your research, whether you are going to be an entrepreneur or you work for a company, you need to get resources. Whether you get human resources, labor resources, technical, financial resources, you need to convince the stakeholders. You don't want to fail your first effort to get the resource later in your career. You want to fail your first effort in the classroom or in the research lab on campus,
right,
where you don't have to bear
get
the
some
consequences.
practice here, yeah.
Yes. And the career mimicking challenges is the last one. And I can't emphasize enough that there are a lot of challenges in the real world career. For example, you will have to manage your project. You have to set up deadlines and you have to adhere to deadlines. You have to estimate the cost, the time, and what is your backup plan if things are not going well? And then what are the alternative approaches? What if you have a team member who is not working well with you? How do you deal with this team science problem? And the most important is you don't have a teacher. You don't have a textbook. You have a customer, and the customer pays you. And you need to find out how you can learn to solve the problem all by yourself. All these career mimicking challenges are, I think, are very important to develop anyone's capability in their own later career. In addition, the good experience also include one-on-one interactions. You have a lot of one-on-one interactions opportunities in the lab. This can be happening between you and the advisor or the professor, between you and senior students, or between you and your teammates. There are opportunities for internships and job positions directly developed from your work in the research lab. Really depends on who is sponsoring the research you're working on.
I'm wondering, from your experience working with students, what are some of the things that students might find challenging about research?
Yes, the most challenging aspects from the student side, in my experience, is to find enough time to do research. You know, most of the undergraduate students have this curriculum, and the curriculum itself is already a heavy load on your schedule. And if you don't spend enough time in the research lab, your time in the lab will be totally wasted. For example, I require undergraduate students in my lab to spend at least 10 hours per week. Well, you don't have to do that every single week. For example, you have an exam week, feel free to just dismiss yourself from the lab, just be absent the whole week, that's fine. But if you work in the lab in that week, just spend 10 hours. Why do I require that? In my research, most of my work is experimental. So you need to plan ahead what you want to set up. In a lot of cases, for example, you need to spend 10 minutes just to find the right size screw. And then if you just spend 1 hour in the lab, you'll see very likely your setup is halfway done. And then tomorrow you come in, your setup has already been disassembled.
You have to start over again, right?
Yes, you have to scratch.
You've made no progress.
Yes, start from the scratch, which is not benefiting anyone. With that said, the time conflict or time constraints is the major one. Other than that, the undergraduate student can easily get lost because there's no assigned homework. Sometimes there's not a very good formulated the definition of the problem, because as I said just now in the research, right, there is a problem in, let's say, the bicycle is not working, right? So how do you solve it? Right? So you want to formulate, for example, the wheel is not working, or, the steering system is not working, or just the foot pedal is not working, right? So you have to find out why. And sometimes the finding why, in other words, problem identification, is challenging enough for the students to get lost. And then the third one really is some of the learning curves of the fundamentals and also the equipment can be steep. As long as you are motivated to do it and you are interested by the direction, that technical challenge is not a problem.
I think a lot of students or prospective students might be hearing this conversation, and they might be interested in taking the leap and doing this and trying what they've heard, want to give it a shot at doing some research with a faculty member. But they might be wondering, do I have the right skills or the basic knowledge to be a good researcher? What are the things that are essential for students to have to do research? What do you look for in a student applicant for a research role in your lab?
Yes, I'm very glad that I can talk about it here, other than I have to repeat myself in every single course I'm teaching.
Just play this episode.
Exactly. So I would say, following what I just said, right? So the motivation and interest is the most important. If any student, if you feel yourself is motivated enough, you have strong enough interest, let's say for climate change, for renewable energy, for quantum computing, whatever thing that you are interested at in contributing to make the world a better place, you need to talk to faculty member in that area and find out what opportunities are there.
That personal motivation is really important to keep you coming back.
Exactly, especially with the expected failures in your research. And you need this motivation to keep going. So other than the interest and motivation, I would say the sense of responsibility is important. You want to check with either your teammate or your professor from time to time, make sure they are not just waiting for you and then you are not going to plan to stop by. And then independence of thinking should be one of the items on your personal skill development list. Because if you are not interested to be independent, at least now, then you shouldn't come to a research lab. Other than that, you should have a strong attention to details, because the problem is an open-ended problem and the solution might lie well beyond your initial plan. You need to keep your eyes peeled to really kind of track all this kind of small phenomena, small data that show up as a surprise, but really kind of bear important inspiration about how you solve it. So this attention to details, again, requires some time to develop. So you don't have to have that before you come to the lab. And other than that, enough time, as I just said just now, and then be open to learn.
That's fantastic. Great information that I think could be very powerful for students as they're considering exploring opportunities. I wanted to talk specifically about your lab. What is the research that you do? What are some of the open-ended problems that you're trying to solve?
Yes, the research idea is under the overarching goal of studying light-matter interactions. And in the application-wise, I'm mainly developing optical fiber sensors for food and water and for healthcare instruments. So for food and water, I'm part of the Center for Advanced Research in Drawing, which is NSF Industry University Collaborative Research Center. And I develop optical fiber sensors for drawing industries. And these industries include food industry, pharmaceutical, pulp and paper, textile, and so on. So in that research center, the industries actually chip in the research money to support our research, and they evaluate our plan of research. And only the plan can solve their ongoing challenges and have a possibility to be implemented on their manufacturing line. They will support it. So you can see that the students working on these projects, they actually have regular meeting, monthly meeting with the industry sponsors. So the industry sponsors sometimes can be harsh, can tell them that, what you're working on is totally different direction from what we expect. In this particular direction you are going on, it's not going to be useful. So, and we appreciate that, because this is how we make sure our effort is well aligned with the industry interest, and our final research outcomes can immediately help the challenges existing in the industry. right? So a few sensors I'm developing there are optical fiber food moisture sensor, which can actually measure in real time how much water is still left inside the food. For example, if you say potato chips, right? So you want to remove the potato chips from the hot oil before it's burnt, right? But you don't want to remove it too early because otherwise it's not crunchy, right? Then how to tell in the real time how much water is still left inside? It's actually very important. It's not just important for the quality of the food, but also it's related with energy efficiency of the manufacturing process. It's related with the food waste, and also related with the process control, especially when we talk about AI applications. And then another example on the healthcare side, I'm working with a few other professors on smart catheters. So we actually want to measure the pressure, we want to measure the chemical compositions of the biological samples inside the patient's body so that the physicians can make the right, or I should say, the optimal decision based on the real-time in situ measurements.
It's fascinating.
Thank you.
How do students help you with these projects?
Oh yes, my students are amazing. They conduct research and they also formulate the ideas, they apply evaluation, they present this to stakeholders, and they constantly educate me on this. For example, find the right parts from the market and purchase it, right? And then evaluate whether a certain model from a company is better than the other model, and then find the right one. So a lot of time spent on this kind of comparison actually allow them to know better what is available on the market and what is the technique that we are competing against. So actually, I already have 2 US utility patents, and we hope that we can find an industry collaborator to license these patents because we know we are better than existing parts on the shelf.
Is that an example of how the students are educating you, what you just described, sort of that market comparison, or are there other ways? I want to know more about what you're learning from the student researchers in your lab.
Yes, that's an amazing topic. I really hope that the potential students who are interested in joining lab to know better. At least in my lab, and also in most of the professors that I know, students educate the professor about the research they are doing. Why? Because students are the people who spend most of the time in that particular research and who obtain, if not all, most of the results from that research. And students apparently know more, not just about details, but also in principle should about the fundamentals than the professor. Well, you might ask then, why would a student need a professor, right? So the professor still needed because the professor need to have the initial direction defined. And generally speaking, professor have a broader knowledge beyond the specific project that students is working on. So professor can constantly bring ideas from different projects, different direction, different disciplines into the project that students is working on. But for the projects that students is working on, the students are the king of the knowledge. So with that said, my students educate me not just on the fundamentals, not just on experimental conditions, the final results, but also they constantly bring new ideas by reading literatures by themselves, not by me. But they saw a good paper published on Nature, they bring that paper to me, say, hey, professor, I found this paper. How about we look at it? How do we incorporate this idea from the Nature into my project? And they also educate me on, for example, they constantly talk to stakeholders much more than I do, right? And they can tell me, oh, professor, the other company, company A, John, told me that they are also interested in another thing that we were not including in our initial project definition. Maybe we should consider to add this to make our technique even more attractive to them. So you can see that students doing this to me, of course, is benefiting me, but also they become more independent researcher, and the potential employers can identify that. Believe me, they can.
You've painted a picture of a wonderful two-way street of collaboration that goes both directions. In general, if a student is interested in doing research, how do you recommend they find out about opportunities that may exist and get involved in them?
It's not intuitive, to be frank. There is no available platform where the available research opportunities on campus can be viewed in the same website or in the same office, or just talk to one person, you'll get it. And the reason is because research is organic. Like even in my own lab, every single month, we change our topic either slightly or completely. So with that said, if we, let's say, ask the department head to collect all the information from all the faculty members, we'll have to do that weekly.
Real time. It changes that fast.
Exactly. Yeah. So with that said, the best source of the potential research opportunities is the keywords from the web pages of every single faculty members. I know you have to go through all these faculty members, right? So if you go to your department website, there should be a list of the faculties. You can click the name of each faculty member. You should be brought to the specific web page for that particular faculty member. Then if you scroll down, you should be able to see keywords, recent publications. And by the way, some faculty members a lot of them are too busy, including myself, are too busy to update that recent publication list. So you can use Google Scholar, search for the name of the faculty member, and you will see the recent publication of that person. Then at least read the keywords. See whether there's a match between what you are excited about and the expertise that faculty member has. And if you already found one, just read 1 or 2 recent publications. After that, you need to reach out proactively, either by email or directly just go to that office of the faculty member and knock on the door. Just say, hey, professor, I saw your research on your website. I'm interested. Do you have an opening? Okay, so the other resource I would say is the teacher of every single course that you are registered. Not every single faculty member is doing research, but most of them do, right? Just go to the office hour, talk to the faculty member. What is the research of yours? What are you working on right now? What do you plan to do? Can I go to your lab to have a look, right? So believe me, most of the faculty members will be thrilled and they will not be able to stop themselves when they start to talk about their own research. So don't think in a way that, I'm bothering the professor's in the office hours and he or she is occupied. No, don't think that way. That's another way to advertise yourself. Because by talking in person to a faculty member, you can show the other side that you are a responsible person, you can organize your words, you can freely communicate, and you care. That, as I said just now, is one of the most important things when the professor is decide whether to take this student.
So it often starts with a conversation.
Exactly.
Really great advice there. And I just wanted to add a few things in addition to what you've recommended, Shawn, about reaching out to faculty. We would encourage students as well to also reach out to their academic advisor to have a conversation about their interests and about finding research opportunities. Those advisors often have connections and ability to make those connections. We've also got some resources on WPI.edu that outline frequently asked questions about student research opportunities and how to find things like funded undergraduate research and summer research opportunities for students. There's also information on fellowship and scholarship programs connected to research work. You'll also find information about one example of a WPI program that supports student research opportunities. It's called CLIMB at WPI. That stands for Coaching for Leadership, Innovation, and Mentoring in Biomedical Research. It helps students learn about biomedical research as a career and get help finding research opportunities at WPI. And it provides mentoring over multiple years. We'll have a link to all of this in the show notes. Shawn, before we wrap things up, I want to give you the chance to sort of leave folks with some parting thoughts. Maybe somebody's still on the fence thinking about, I don't know, should I make the leap? Why don't you make your closing argument for why student research is worth giving a shot?
Yes. I think with the AI competition on the horizon, and also with the research experience that I had as an undergraduate student in the past, I would say if you are interested in exploring the research opportunity, just do it. Don't think twice. Just do it. Find the faculty member that match your interest, and then proactively contact that person. Recently at MIT graduation on May 28th, 2026, Lisa Su, the CEO of AMD, said that one of the best parts of MIT for her is actually the Europe, which is short for the opportunities as an undergraduate student to work on the real research. WPI also have these resources and these opportunities. I hope more WPI students can take the initiative to talk to professors and get themselves involved in research. This is not only going to help the students themselves, but also help WPI, the education.
Well, very well said, Shawn. Thank you so much for joining the WPI podcast and sharing your insight on student research opportunities.
Thank you very much, John, for having me. I'm very happy to share my personal view on the research opportunities.
Yuxiang Shawn Liu is an associate professor in the Department of Mechanical and Materials Engineering at WPI. Thanks to you for listening. I invite you to follow the WPI podcast wherever you get your podcasts. You'll also find us on wpi.edu/listen. On that page, you'll find other podcasts from across campus and WPI News on the Go. That's a collection of audio versions of stories about our students, faculty, and staff. You can keep up on everything happening at WPI by asking Alexa to open WPI. This podcast is produced at the WPI Global Lab in the beautiful Innovation Studio on campus. I don't have a favorite building on campus because, you love all of them equally, and even if you did, you wouldn't say. But it's a pretty fantastic spot. Come for a campus tour and you can check it out. There's a bunch of people on the first floor tinkering and making things in the makerspace. Upstairs, you'll find students honing their entrepreneurial ideas in the I3 lab. There's some great places to study too. Anyway, I got sidetracked. I want to thank PhD candidate Varun Bhatt for the audio engineering help on today's episode. Please join us next time for another episode of the WPI Podcast. I'm John Kane. Thanks for listening.